That's a play on words. Hey, welcome back to Frank's Modelworks. I'm Frank. So that is a little bit of a play on words. In this episode, we're going to be looking into how to print clear parts. Not windows. We'll talk about that in a second. But headlights, taillights, marker lights, turn signals, that kind of thing. In this series, and we're up to part 7, in this series we've discussed taking the plunge into buying a printer, or at the very least, buying products that are 3D printed from reputable sources such as Josh Reese over at VCG Resins, Joel Mendoza over at Iceman Collections, Matthew Inman at MCV Products, and Joseph Osborne of Fireball Modelworks. If you remember, I'm of the opinion that you should do both, and I just did that thing again. I don't know why I do the things that I do, but anyway. I'm of the opinion that you should do both. You should buy both a 3D printer, and you should continue to buy products from those vendors, because they're going to have access to files and products that you might not have access to and be able to print yourself. That said, we then went on to describe how your first week with a 3D printer is going to be pretty difficult, and why that would mean that it's best to consult a knowledge resource. And at that point, I recommended Scale Speed Garage, founded and run by Chris Bell. And there's going to be links to everything in the description and in the comments when people ask me for links. So we got through that first rough week by calibrating our resin. We started doing nice prints. We started printing bodies and experimenting and narrowing things down and printing out parts and having fun and then using those parts. And where I last left off, I had printed out a 1964 Ford Country sedan station wagon that I was going to build as a gasser. The way things work, it might have been a while before I got to that, and my friend Dave Wood over at Woody's Scale Model Garage reached out and he goes, "That's a really nice." He fell in love with that country sedan, so I actually sent it to him. I'm gonna print out another one for myself, and maybe down the line we'll do something like a buddy build or something. I still got to talk to Dave about that. But one thing that I haven't spoken about, and it's because it's something that I've been experimenting with for a couple of months now, because it's kind of difficult, is printing the clear parts. And like, again, the windows that you receive, like from a file, a kit file, like say from Andrey Bezrodny over on Cults 3D, is gonna contain what looks like the outlines for the windows and the glass on the car that you're downloading and printing, but they're actually bucks for vacuum forming. Or you could use them as templates to just cut the windows out of sheet styrene, which in my case might be the way that I go, because I don't know if I'm in a spot to get a vacuum form machine. I'm packed in pretty tight here, and it's an added expense and an additional learning curve. But I'm sure it's at some point it's going to be in my future. But those aren't the only clear things that are on a model car. And, you know, when you buy a kit, the glass is on the same sprue with headlights, taillights, marker lights, that kind of thing. You can print those, because for the most part, like, most taillights and headlights have a texture in it, and they don't require the same amount of optical clarity as a window, a windshield, a backlight, side windows, stuff like that. So what I've been experimenting with over the past couple of months and failing miserably at was trying to print those things. And I think I might have finally had a breakthrough. And that's what this episode's going to be about. So without much further ado, and I realize that I'm long-winded. Most of you listen to me with the video on in the back, and they're just listening to me talk. That's why I'm long-winded. We're going to talk about that at another time. But let's put you up here and show you what I'm talking about, and then I'm gonna come back and show you my settings in Chitubox, show you the resin that I use, and also my support settings. So hopefully you could start printing clear parts. There's also a post-print process that involves steps that we're omitting a step that we previously did when we 3D printed, and we're adding a step. So let's just get started. Shut up, Frank. Comes the play on word. Let's make something clear. So most of us are used to, when we buy a model kit, getting a clear sprue that will have the windshield's not on here, but I cut it off already, but the backlight, the side windows, the glove vane windows. But you'll also have things like your turn signals and your headlights. In some cases, some kits will provide the taillights on the clear, or they'll color them for you. They'll be colored red, which is very convenient, and I appreciate when that happens. When you download and you print out a 3D kit, especially from a designer like Andrey Bezrodny, he does provide these parts. The problem is, if you print those things in regular resin, you'll wind up with something like this. And these are the headlights and taillights from the 1964 Ford Country sedan. So that's all well and good, if you could see that, to print out that headlight. But painting that silver is not really, I mean, it would work. Maybe you paint it silver, chrome silver, and then put Tamiya X-22 clear over it. I guess if you have no other option. One thing to keep in mind is a lot of headlights are standardized, and they're not necessarily vehicle specific. So in scale, these headlights are 6 millimeters in diameter, which would equate to roughly 6 inches in real life, because they're 1/25th scale. This is a headlight, and I believe it's supposed to be like a T3 headlight, and this is out of the Revell 1968 Chevelle. These headlights are interchangeable. So if you have a kit around, or extra parts from a kit, whatever the case may be, and you're printing out the headlights, take a measurement. Grab your calipers and put it on a ruler, see what the diameter is, and then measure it against something in your parts box. That's not necessarily the case with taillights. Taillights are usually either vehicle or body line specific. So that's where you're really going to need to learn how to 3D print your clear parts. And in order to do that, you're going to have to use clear resin. So, which is, it's fine. It's not difficult. It's not going to be the same settings that you're using to print using whatever opaque resin you're using. You generally aren't going to be able to use the same settings. That has to do with light bleed through, several factors. Light bleed through, the general characteristics of the resin itself, and the forces that are placed upon the parts that you are building. And I realize right now people are screaming at me going, why are you putting that away now? Because I need this. I need to print out a 64 Ford, and I need to not lose these parts, because I'm going to be building one also. So, and I will lose them if I leave them here. I'll start hitting them and knocking them off. But, so, what did I do? So, I go into Chitubox, and I arranged my pieces on the build plate so that they'll print out. Now, one of the characteristics of a clear part and a resin printed part is that they're printed on supports. So the problem with that, it provides a little bit of a challenge for you, in that the supports are going to create almost like an imperfection in the optical quality. Like they place a pimple on every part that you print, so you try to put them on the underside and so that from the bottom nobody's going to see them. But with a clear part, you're going to see them regardless. So in this case, you're actually trying to put your supports in a place where you can't see them. So I'm gonna put you back on the tripod and discuss the real meat and potatoes of printing clear parts happens in Chitubox. And let's get to that right now. Okay, so as you can see, we have Chitubox open on my desktop. Before I get to that, I'm going to show you the clear resin that I'm using. The resin that I'm using is Elegoo ABS-like 3.0 Pro translucent resin. And this is in a 2 kilogram bottle. It's actually almost like the same price as 1 kilogram of the water washable that I use. Go figure. This is, now, like I said, it's not water washable, so you're going to have to use either a dedicated resin detergent or isopropyl alcohol to clean these parts after you print them. It's a consideration. Do you have an allergy to isopropyl alcohol? Do you have an allergy? I mean, you got to be careful with the detergents and the alcohol. It becomes more of a safety concern because having that much alcohol on hand is more of a fire hazard. So keep that in mind. I mean, everything we do, everything we have is a fire hazard if you think about it. Most of it is. So I'll have a link to that in the description. I got that off of Amazon. The thing with the clear resin is that it has different properties than opaque resin, which requires different ways of setting your supports, which I'll show you in a second, and also the settings, your slice settings for when you're slicing the file to send to the printer. So right now I'm gonna try to figure out a way to, focus on the screen like I've done once before, which is it's a pain in the neck, but we'll figure it out. All right, hold on. Here we have the headlights and taillights set up for the Andrey Bezrodny 1977 Pontiac Le Mans Safari wagon. So you have the one headlight and you have the taillights. Now you'll notice here that there's detail on these parts, which is molded into the plastic that's on the real taillight. The opposite side of these parts are plain. So obviously the parts that are going to be showing from the rear, that are going to be showing their face, are the ones with the texture on it. So we're going to be placing as many supports as possible. We don't even really need to put that many on this face itself. So what we're going to be doing is strategically placing them. And so now over here we have the headlight itself. So now which can you tell, because there's texture on both sides of the headlights. You see there's texture, there's detail on this side and there's detail on the opposite side right there. So how do you tell? By the cross section. Now if you look at the cross section of that headlight, you'll notice that this is convex. In most cases, in a large portion of the cases in automotive applications, particularly on American automobiles, the convex surface of a headlight is going to face outwards. So how do you tell that, like, how do I know this is convex or concave? Very simply, I Google it every time I need to because I don't remember it either. But generally speaking, if it bulges out, convex. If it bulges in, it's concave. So concave, caves in. That's how you remember it. Do you really need to know that? No. The side that bulges out in the vast majority of cases will be the outside of your headlight. So that means I'm going to be putting supports on this side and on these edges. Very few supports on this side, but there's a consideration that we have to make. So in order to make this easier on us, what I'm going to do is I'm going to go into the rotation dialog and I'm just going to hit 180 degrees and flip it around. So now all of the faces that are going to be facing outward towards the world are now in the same plane, and we're looking at them in the same way. Okay? Now, to make it easier, my experience has shown, and I don't know if this is an axiom of truth, but my experience has shown that the least amount of surface that you're printing at one time produces less suction on the part, but it also leaves you with less ability to support it. So it's almost like a double-edged sword. Optimally, if you print this way, you could wind up with really bad build lines, but because there's a texture, we're not so much concerned about that, because it is generally going to be hidden by that. And like I'm saying, the problem is I would have to place all of the supports either on the sides and on the bottom, which could lead to the part failing because it gets pulled off of the build plate. So what do? Do we angle it? In my case, from my experience, and as you saw on the parts, I do angle it 90 degrees, parallel, 90 degrees from where it is now, parallel to the build plate. Because this way I can add supports to it to ensure that I have a minimal amount of occlusions, which is going to be witnesses of the supports in the part itself. Like occlusions are going to be little imperfections inside the clear part from the supports. So let's do that now. In the y-axis, and I will select all of these parts. In the y-axis, I want to lay that down flat, so I'm going to hit 90 degrees. And now, the other way. Beg pardon. -90. So now all the parts that are going to... they're going to lay flat to the build plate. It almost looks like these parts, it might have something to do with... no, they're sticking up a little bit. See that? They're off the build plate. Now, I have noticed that some designers deliberately will angle parts that way. They'll orient them that way. So, you know what I'm going to do? I'm going to leave well enough alone and go based upon my experimentation. And I'm just going to add supports to these parts as they are right now. So I go up here over to the dialogue, up in the right-hand corner to add the supports. So that lifted the parts 5 millimeters off the build plate, as you saw. If I go back to the other dialogue where I can individually move the parts, you'll notice that they drop back onto the build plate. Watch. See? They drop back down. So if I hit that, it will automatically raise it 5 millimeters. So if you want to raise your parts a little bit more, that's fine, but just keep something in mind. The higher your parts are in this axis, like off the build plate, the longer the print time. So as it stands right now, this is going to take 26 minutes and 46 seconds according to Chitubox. In reality, it'll probably take closer to 40 minutes once we get it sliced and all that other happy stuff. So I'm going to use light supports, and I'm not going to use auto support because I don't like the way it does it. So what I'm going to do is come in. I'm going to use half tips. This way it doesn't, the supports that I add don't obscure my vision. So what I'm going to do is use the minimum amount in the visible part of the part so as to avoid occlusions. But I have to put some on the bottom because I can't just put them on the side because the part will fail in this right here. Wherever, like say I put it here, the part's going to fail in the detail that's on the back. So you got to put a couple, as few as possible for clear parts. And on the real headlight lenses, you might actually notice that there's, you know, there's stuff like this. There are occlusions for whatever reason. Maybe that's how they come out of the mold. So, do we put one? Let's live dangerously, folks. Put one there like that. Okay? So now we know when this thing is printing, it's first going to print this little raft. These are actually part of the supports and not a raft itself, because I'll show you my settings for supports in a second. So it's going to print this base first, then it's going to print the supports, and then it'll start printing the part. So now, like, there's a bridge between these supports and the part itself from the bottom, so that generally speaking, nothing will not be printed on I won't lose any detail on the underside. So then I'll add supports to this dimension as well, kind of in the same place as they are, corresponding. So I'll need to put one. So over here I'll put one there, and I'll put one there. I'm splitting the difference across the length of the headlight. It's a little wonky the way you have to move around in Chitubox. I had them like, and this is, believe it or not, this is probably overkill, but one of the things, they do have to be well supported, because the suction pressure of, depending on your printer might lift the build plate up. My printer tilts the resin vat away, and the suction associated with that movement, regardless of how your printer does it, could affect the ability of the part to print completely. And I'll show you my settings in a second, which will show you why I use so many supports. I use so many supports because my settings are such that there's not a lot of depth, you know, insertion depth of the supports into the part itself. So that has two benefits. The parts come off the supports easily, and they leave less of a witness that they were there. So just like I did on the headlight, I'm going to do the same thing. Now, if I had hit auto support, I don't know how Chitubox does it, but I don't know if it would work very well. What my experience had been that it didn't work very well. So like you see there's support here, so I'm going to cut the distance on the outside like that, so as not to leave something unsupported. I try, experiment, see what you could do, but this is based upon a lot of trial and error on my part, a lot of wasted resin as well. Luckily they don't take that long to print, but all right. Sure, I realize this is overkill, but there's a method to my madness. All right, so now those parts are supported, and now we'll take a look at my support settings. So if we look over here, we'll pan over, and we'll try to zoom in a little bit. Pardon my magnificent camera work. So my basic settings are my tip upper diameter is 0.20 millimeters. My raft shape, I have no raft shape, so it's not going to print a shape. These are just parts of the supports. My touch tip distance in millimeters is 3 millimeters. My support angle is 45 degrees. My advanced settings, and this is where it's going to make a bigger difference in... This is basically the reason why I have to use this amount of supports, but the result is less damage to the part lifting it off the supports, and it lifts easier off the supports. So, my touch, I have no touch shape. The other choices would be a sphere, so I have no shape to mine. My contact depth is 0.05, so 5 microns. It only goes in 2 layers, well, 1 layer in the setting that we're going to be printing at. A little more than 1 layer. So 0.05. My connection shape is a cone. The other option would be a pyramid or a skate. I go with cone because I like ice cream. My tip upper diameter, 0.2 millimeters. My tip down diameter, 0.8 millimeters. And my connection length is 2 millimeters. So those settings give me something that I can use. And this part will most likely print well. This little raft here. So now that we're done with this, we'll go back over to where it's editable. And this is where we hedge our bets. So I'm going to choose the headlight. And although I only need 2, we're going to print 6. Just in case. Because, you know, extras are always good to have. And then for the taillights, you can go over to the dialogue. Let me zoom back out. Superb camera work, Frank. You really are. You're amazing. This is Academy Award-winning stuff for cinematography right here. So in Chitubox, you can once you have one part or any part selected, you select the part, you touch control, you select another part, they're both selected. So for the purposes of copying, like we'll just make 3 so that we have 4 of each. Because we already, so just take these, arrange them so that they're not touching each other. Like if you touch, you see how they turn red? That means they're in conflict. And they won't print properly, they'll just smash together. I don't even know if it'll let you print something that's touching like that. Or slice it or send it to the printer. Alright, so let's just say that's going to be what we're going to print. So what we would do is we would select all of them over here. Notice they all turn blue. We go over to the corner over here. You see my cursor in the lower right corner. We go to slice settings. And that's going to bring us over to the meat and potatoes of what's going to make this thing work or fail. So, on my opaque resin, in this measurement, my layer height, my opaque water washable Elegoo 8K resin that I use in space gray, my layer height would usually be 2 microns or 0.020 millimeters. In this case, I want a little bit of a thicker layer height because my experimentation has determined that this was the only thing I could get to work. So I'm just trying to get it to work for you. I used the bottom layer count of 5 bottom layers. Those are the burn-in layers. They are burnt at 35 seconds each. So that's it's not a It's not a ridiculous amount of time, but it's 10 seconds longer than my normal burn-in layer. So 5 of those at 35 seconds each gives very good adhesion to the build plate for what I'm printing. And like I said, my layer height at 0.040 millimeters, my exposure time, I found the best one was 3 seconds. Anything less than that, I had nothing but failures. Even the bottom layers would start to pull off. And I lost actually a couple of FEPs, or PFA films, because parts were stuck to those instead of to the build plate. My transition layer count stayed the same at 5, and my transition type is linear, and I didn't change any other settings. So with that, when I slice this and send it over to the printer, I reasonably expect this to print. So now I'm going to set you back up, and I'm going to show you what the results, not necessarily of this, I'm going to save this later on, but I'm going to show you what my results are, and then the post printing process that I find most helpful. Okay, so hold on a second. So having sent these to the printers, I don't know, I tried the white piece of paper is, I'm trying to show you if that there's a subtle difference, and I don't know if it's showing up, but it's definitely showing up in person between these two. These are the same things printed, now with the exception of that, which is some paint that got onto it, that little stain. Do you see any difference between these? Because in person, this one is yellowed significantly, and the reason why is because these two were cured in the curing, in my curing station. Now, in my research and in my experimentation, a lot of people have stated that they'll do things like submerge the parts that they want to cure in water and then put them in the curing station. I didn't try that because I went to just a different, I cleaned these parts off using isopropyl alcohol. These were not cured in the curing station. They were just cured by printing them. So what I did was I cleaned them with isopropyl alcohol, sprayed them off with my compressor, and then I applied Tamiya TS-13 clear to them. And it actually cut down significantly on any parts fogging, if you see. Not to disparage another producer of parts, but I have over here some parts that were printed on clear resin, and you could see a definite fogging or obscurity in these parts. Not infinitely usable, and they are going to be used, but these are closer in appearance to styrene. If you see the sheen. So that's using Tamiya TS-13 without curing, post printing. If you want to feel better, I actually cleaned these off, sprayed them with my compressor to get the alcohol off and whatever resin was still on there, and waited like 10-15 minutes and then sprayed them with the TS-13. And it's been several days. I don't see any. And because it's a lacquer, granted it's a hybrid acrylic lacquer, but if you don't go too crazy, you could very easily use Tamiya X27. I would probably thin it with their X20A acrylic thinner, which it would be milder than lacquer thinner, but light mist coats. You could paint this taillight very easily with this. You could mask it off, there's a lot of debate. Oh, can you put this paint out? Here's the thing. Let me widen out a little bit. you can put properly applied anything over anything. So that whole thing where you can't put lacquer over enamel, you can, it's just there's a learning curve, and you have to apply it properly. So if you put light mist coats of lacquer over enamel that's fully cured, if the enamel is fully cured, it's undergone the chemical change that enamel goes through in order to fully cure, and then you spray very, very light mist coats and build up your color with lacquer, you can absolutely apply a lacquer over an enamel. You can apply a lacquer over acrylic. It's the same thing. You just have to be very careful. You can't hose it on like you're putting out a fire. So, that said, if you use the Tamiya TS-13, if you can't get that, like say in Canada, I know it's going to be difficult. I don't know how many Canadian viewers I have. I know it's going to be difficult to get this moving forward. I don't know if this is available at like your arts and crafts stores, but this one is actually painted with Patricia Nimox, the magic name in crafts. Okay. Plaid Decorative Crafts Clear Acrylic Sealer. I didn't check the material safety data sheets on these because, you know, I wouldn't probably know what I'm reading anyway. I know that they smell alike and they perform very similarly in my experiments. And like I said, this one's done with Plaid. This is actually the Plaid is the stuff that I put over my decals when I printed the Mod Top decals a couple of months ago. If you look at these, they are very similar in sheen and finish, and the spray itself smells very similarly. Now, if you can't get access to this, and you can't get access to this, you could absolutely airbrush this on. No problem. You probably have the same effect. If you don't have access to any of that stuff, you could, I guess, brush paint this on. I would thin it and build up the coats very, very lightly, very carefully, so as not to affect the acrylic that's underneath. As far as other stuff, I don't have any other stuff to test with it, so that's my thing. So, when using the resin, clear resin that you know what? I'll do this over there on the tripod. Hold on. So, when we used Elegoo ABS Light 3.0 Pro translucent photopolymer resin, which just means that it gets cured with ultraviolet light. We used that resin in Chitubox. We arranged our supports and our parts in such a way that we could overcome the suction forces of the print. And then we applied a slice setting that's a little bit more robust than the typical printing that I do with opaque resin, water washable opaque resin. In so doing, we created parts that printed successfully. My first thing was, the first print I did, I tried to do the cones of calibration that like I did in episode 2, and not one of them printed right. And I was just using the settings that were in there from when I was printing opaque parts with water washable resin. Every one of them was a failure. So then in my search and my research and trying to find out, because there wasn't a lot of information out there, I saw that older resins, older posts that I would see like on Reddit and stuff like that were like 6 seconds per layer, which sounded absurd, but it was a really old post, and I'm like, it can't be. So I tried to get something. There's a spreadsheet on Elegoo's website that is not very helpful. I couldn't get all the cells open, and it also didn't have the Saturn 4 Ultra. So I didn't want to go by that. So I found a post I believe it was on Reddit, where the guy, the person speaking actually said, you know, the spreadsheet that Elegoo has, some of those numbers are absurd for the resins that are out there today. So, like, where they said 6, 3 might be sufficient. So, all right. So I gave that a shot. It didn't work at lower layer heights, so it didn't work at all at 0.020, 0.025, 0.023, 0.03, 0.035, 0.04, 4 microns was the lowest layer height I could get. And then I did the multiple exposure time tests with the cones of calibration, and one of them printed, but because it was clear, I couldn't see the results. I couldn't see if, like, all the stuff, if you remember from that episode, you're supposed to look at the cones and then take the sword out and stick it. I couldn't see anything because my eyes are so terrible. I try, and now if you remember, you're not supposed to cure the cones of calibration. So then I tried spraying it with primer, and it messed the whole thing up. So I'm like, oh, we're gonna have to wing it. So I determined that thing that I had printed was at the 3-second exposure time at the 4 micron layer height, and I go, all right, damn the torpedoes, and I whipped up those parts and sliced them, sent them to the printer, and I printed them, and they came out okay. Then, not knowing any better, I was reading, you know, be careful with the curing process, cure it in water, or don't cure it at all. So then I cured it for my regular 6 minutes, and it yellowed. Not significantly, it's very, very subtle in person. It's more, you can't even barely see it on the camera, but in person, it's a little bit more noticeable. It doesn't look like an ashtray from the 70s. I mean, if you stick that thing in the cure station, I would imagine for like 9 minutes, and that thing's just gonna turn brown. So I'd seen an episode of Uncle Jesse where he used Rust-Oleum to clear coat, and I didn't have any of that on hand, but I did remember that I had the Plaid on hand from when I was doing my decals. Although the Plaid that I used for my decals was matte, I did have a can of this, which is gloss. So I sprayed that on to this one, and it looked great. So I said, all right, well, and I had remembered the TS-13 had very similar characteristics to the Plaid, so I tried that on this one, and it came out okay. And so there we have it. I have another episode of 3D printing stuff that I could share with you. Let me know. I mean, this is actually a thing where you have to understand. I'm by no means an expert. I'm not an engineer. Like I said before, I don't read material safety data sheets to find out what's in stuff, because what do I know? I don't know what that crap's gonna be anyway. I'm a teachable monkey. You know what I mean? So this is a situation where, as a community, we have to get together and put our heads together and say, what do you think? What do you think of my results? How do you think I did? And do you have anything to share? Now, I'm not, you know, like, usually the people that are gonna respond negatively have already done so, so they won't get to this part of the video. I'm actually asking for your input to think about what should I think about my results here. Are they good results? Because I'm pleased with these parts. So right now what we're going to do is we're going to do the ultimate test, and I'm going to take a part off. And it came right off. And it's intact. So let's try to get one of the taillights by twisting nice and easy and not trying to break it. And it's not coming off immediately, but it's not actually sticking. They're not robust. The depth of the contact for the the supports is not such that this is really, really on there heavy. So let's see if we can get this off. I know it might sound terrible, like crinkling you here, but it looks like I got that broken away. And there's the part. It came off intact. The occlusions are such that I would call this a usable part. So I'm happy with the results. Let me know what you think, because I'm interested in your opinions. If you use my settings, like I said, I have an Elegoo Saturn 4 Ultra, the resin that I showed you my slice settings, and I showed you my support settings. Hopefully, and my resin was heated. I heated my resin with the hairdryer first. I made sure it was close to one of the bottle itself was close to one of the, I have forced air heating in my house. So I left the bottle, sealed close to one of the ducts so that it wasn't really cold. Brought it down here. The machine was saying at the start of the print that it was 22 degrees Celsius. And by the time the printing was done, it was up to 29 degrees Celsius. So that might be a factor. Just give you all the information that I had to produce these results and let me know what you think. And if you're 3D printing, try them out. Let me know what you think, and maybe this is what we have to do to come as a community to come up with a solution, because I couldn't find any model car specific information on printing clear parts. So let's see how we do. All right. With that in mind, as always, I got Frizzo's back. I appreciate your support. And until we speak again, my friends, take care of yourselves and be well.